Hey there. How are
Hey,
you?
how's it going?
Going well.
Pretty good.
Cool. What's new?
Um, so I finished an exam last week,
Yep.
and
Which exam was this?
this was Blueprint number one.
Yep. How did that go?
Better than previous exam attempts. So I increased by 7 points from my last PR, I guess. I got a 497 on this one.
Got it. Did you use something other than the blueprint cars?
Say again?
Oh, did you use the cars, uh, non-blueprint cars?
Non-blueprint cars, like
Like cars from a different like company?
I don't think so.
All
I've
right.
just been using cars from aamc stuff
Okay.
in the
So,
past.
what's your breakdown?
Okay, bring it up here real quick. Um, did you? Let's see. Did you already accept my other? Let's see. I'm joining from my desktop here.
Yep.
Cool. So
Mhm.
I guess it's the other one. All right.
All right. 124, 122, 124, 127. Got it. Yeah, so I usually have students do um a non-blueprint cars section. So that could be from Jack Weston. They have like cars exams that you can do. You could also use AMC cars. Like you can kind of like select um 9 passages to do in like 90 minutes. Just because the blueprint cars section isn't really that good. So you could just do that moving forward. And also,
Do people tend to score higher or lower on the blueprint
oh,
cars?
not sure about that, but I know that the Jack Weston stuff will be harder than AMC stuff at the very least, but
Yeah.
it'll be like still decently representative. So yeah, it would make sense because Blueprint in general is going to be harder. So I usually have students do like either Jack Weston if they want to have it like hard, like Blueprint hard. Um, but that's still better for cars. Now, I talked to you about like blind reviews, right?
Yes. Yeah. And I did that over the weekend.
Mm-hmm.
So Um, so I was able to pick out specific questions after I did that. For sure.
Yeah.
Uh,
And I can see that you definitely got like for these sections that you got to the point where you ran out of time.
yeah, right. Like right in here, and definitely like for cars, that was a big like mistake I had made like
Mhm.
early on. I had gotten through like you can see here like
Yep.
14 minutes.
Hmm.
So I spent a ton of time just like reading um, and then answering the questions. And I don't know, I realized right around like passage 2 or 3, I needed to pick up the pace. And by that time, it was already too late. And I
So
pretty much
have I
collected B.
have I gone over timing checkpoints with you?
I think you did. I kind of forgot what they were.
Sure, sure. Yeah, I also see that, you weren't able to answer the last couple because you likely,
Yeah.
got ran out of time. But
Right.
generally speaking, you want like questions to be like the time that you spend on questions to not be longer than 1.5 minutes. So you
Mhm.
want to be trying to get it to be like 1.5 minutes for questions max.
Okay.
But yeah, the timing checkpoints, there's 3 of them. So it's essentially like instead of you constantly like looking at the clock, there's 3 checkpoints. So for like sciences, once you get up to question 20, you'll check the clock, and from like the 95 minutes that you start with, which is, you know, like an hour and 35 minutes, you want to have like 1 hour left, right? And then once you get to question 30, that's like the halfway mark, so that'll be like 45 minutes
Mhm.
on the clock. And then once you get to question 40, you should have 30 minutes on the clock. So basically, you're not going to be worried about or you know, looking at the clock, because it could be very distracting until you get to question 20. When you get to question 20, you look at the clock. If you have less than an hour, gently tell yourself to go a little faster. If you have an hour, then you're good. If you have more than an hour, you know, you're better than good. So that's one like checkpoint at which you can adjust your pace. The next one,
Gotcha.
you at the halfway mark essentially. So question 30, and that's going to be like 45 minutes. And again, if you have less than 45 minutes, gently tell yourself to pick up the pace. If you have 45 minutes, you're good. If you have more than 45 minutes, you're good. Better than good. And then the last checkpoint is question 40, and that's when you should have 30 minutes left. So
Okay.
basically, yeah, follow that, like the timing checkpoints. And also, if any question, you know, you feel is taking longer than 1.5 minutes, just guess, make an educated guess, and oops, flag and move on.
Okay.
So ideally, like, you know, if everything works out, like the discipline with not letting questions take longer than 1.5 minutes, you should have at the end, like after you finish that last question, some time left. And that's the best time to have time left, because I mean, you know, if you're on this like 51 and you have time left, it's like, you know, you need to spend that time for these last questions. But if you finish
Right.
59 and you have time left, you can then hit review flagged and then choose which flagged questions you want to spend that time to go over. Like, you know, there's like some questions that you're like 30% sure of your answer compared to like 70% sure, you know, you're going to do the ones where you're 30% sure, unless those ones are going to be more time consuming. So
Okay.
that's like the exception. But generally speaking, yeah, you want to do you want to flag a lot, just so you get to move on. And when it comes to calculation problems, that's really, it's kind of tough to do that, because it feels like, okay, you know, I know what to do. Maybe my math wasn't right. Let me just do the calculation again. But that
Yeah.
that leads to like really, really bad things. So for calculation problems, do your initial calculation. If it doesn't give you your answer, make an educated guess, flag, move on, come back to if you need.
Okay.
So I
Yeah,
think
that makes
if
sense.
you do that for the next test, we shouldn't see, you know, this type of thing.
Yeah.
Yep.
Yeah, definitely. It was I thought it was gonna be way worse, honestly.
When did you do that previous blueprint test?
The the one that was before this one,
Yeah, that was like a
oh, that was like 2 years ago.
okay,
Um,
okay.
yeah, so it was a while ago.
Got it.
That was like the diagnostic half length.
I see. Okay,
Yeah.
cool.
So um,
Mhm.
this was included. This was a free one, and I'll buy the
Mhm.
6 exams next. But yeah, I have the other breakdowns from the other ones.
Yep.
Really long time. Some of these. I felt like it's just as far as like pace wise, the
Mhm.
psych social was pretty breezy at the end.
Uh-huh.
But yeah.
Yeah, that's usually the case for psych.
Mm. All right, so I guess we can start with my blind review questions.
Yep.
In particular, let me just pull up my notes here. Okay. So, start off with message.
So you got this timing checkpoint thing down. Do you want me to like screenshot it for you or something?
Oh yeah, let me do that real quick.
You know, of course, for cars, it'll be like slightly different.
Mm-hmm.
Cool.
So for the most part, on these first couple passages, I did better, and I actually got 100%. But it was the third, fifth that I needed to look at here. Let's see. So it was question 12 and 13. So yeah, boiling chips in a vacuum and vacuum distillation respectively are used in distillations too. Yeah, I selected D on my next attempt.
Okay.
Yeah, it's just, I guess it's more just like a lab technique that I wasn't.
Yeah. So, I don't know what they mean by synergistic. Well, I guess what they mean by synergistically is that they work together. Like, you know, when you have like parts that are greater, or like the whole is greater than the sum of the parts.
Yeah.
But yeah, so they're asking about what boiling chips do and what vacuum distillation does.
Yeah.
What what do you think? What can you tell me about vacuum distillation?
So vacuum distillation will basically reduce the amount of like energy required to, I don't know, evaporate a substance or vaporize
When you
a
say energy,
substance.
what do you mean by that?
Well, let's see. So I guess the heat required, so the temperature.
So what's the what how can you define boiling point to me?
Boiling point is the I guess maybe the kinetic energy of the molecules required to overcome the pressure of air above it.
Yeah, right. So like if I had some container here with some liquid, um like randomly molecules of the liquid will enter into the vapor phase. And so, you know, these are in the vapor phase. That would produce a vapor pressure um that presses down on the actual liquid, right? So now if this was open to the environment, if that vapor pressure is equal to the atmospheric pressure, then you have boiling.
Okay.
So um so
So
now
equal to, not greater than.
what's up?
So equal to the atmospheric pressure, not greater than the atmospheric pressure, I guess.
Yeah. So vacuum distillation would be, would be like if I had connected this to some type of thing that sucks the air out, it's gonna, well,
Decrease atmospheric pressure, right?
yep. It'll decrease the vapor pressure, which would make it, like, if this goes down, it would make it easier for it to reach that atmospheric pressure. So it will lower um that boiling point.
Okay,
So
gotcha.
vacuum distillation, yeah, because like I remember when, like, in lab learning about it or whatever, I always thought it was like to make that suction, to make it kind of like go through like faster or whatever, but then I realized it's actually, the reason is to lower the boiling point,
Mhm.
reducing that vapor pressure. So okay, so that's what vacuum distillation does. And then
Yeah. So is it correct to think about it? So you have like this column of air above your vat there,
Mhm,
and you're kind of removing and sucking away those molecules of air that's preventing
mhm,
the vapor pressure from coming up. Is
mhm.
that like I don't know from boiling over?
Yeah,
Is that the correct way to think about that?
yeah. Like, you know how at high altitudes,
Yeah.
what happens, like, yeah, to boiling point at high altitudes?
Mhm. Yeah, your boiling point is you have less, less atmospheric pressure.
Hmm.
So your boiling point is so the temperature that water boils is decreased, right?
Yep. Yeah.
Yeah.
If you're at higher altitudes, there's less air, there's less, which means that there's a smaller atmospheric pressure.
Mhm.
So so you can achieve boiling point um at a lower temperature.
Okay. Yeah.
And that's kind of like similar to vacuum distillation. It's just that vacuum is like removing all of that vapor pressure. Whereas like high altitude, it's like just lowering that atmospheric pressure.
Got it.
Yep.
Okay. So
So
yeah, I guess so. I think I think that concept I was able to understand a little bit because it was saying that it works to lower boiling points of the substance to be distilled, but then I wasn't sure about the boiling chip,
mhm,
um, and what its role was.
mhm,
From what I kind of remember is that it helps decrease volatility of the boiling substance,
yep,
but I didn't really um, I
mhm.
don't know. That was pretty much all I really remembered about a boiling chip.
Yeah. Because yeah, let's say, so like so for instance, B is talking about like both of these things causing a decrease in the boiling point, and then
Mhm.
the working synergistically, it kind of means like, do you know what it means when it says synergistically like that?
Synergistically, meaning like it works in tandem or it's working with
Hmm.
the system as
Yeah,
opposed
like
to
it would function better than either of those things alone.
in
uh
isolation. Yeah. Okay.
so so yeah, that's something that, yeah, so B is saying that both of the things lower the boiling point. um and then you said that you chose D afterwards, right?
Yeah. Let's see.
Oh,
Provides nucleation. They start
it
more
seems like
rapid.
D doesn't mention anything about
Yeah.
lowering the boiling points. So 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 it's like
Yeah.
D is just talking about lowering the boiling points, and D is talking about the nucleation sites. Um, but it's going to be both. Like, one is going to do one,
Yeah.
the other will do the other thing. So yeah, the vacuum distillation will be the thing that lowers the boiling point. So let me see if you can solve that without knowing what the boiling chip is. Let's see. Lower the boiling points, provide nucleation sites, and then this one, provide nucleation sites, lower the boiling points. So were you more confident that, what were you more confident about? Vacuum distillation lowering the boiling point, or boiling?
Vacuum. I think I was more confident about vacuum distillation than I was about the chip. I didn't really remember much about that.
Yeah, so if you were more confident about the vacuum part, then you would look
Mhm.
for where it says the second part, right, is lowering the boiling point.
Mhm.
So like we know that B and C can't be it, but between A
Yeah.
and D, D says that the vacuum distillation just speeds up the process by removing the most volatile liquid from the distillate. But A is saying that the vacuum distillation lowers the boiling points, right?
Right.
So,
Yeah.
so even if you didn't know what boiling chips did, if you knew that vacuum distillation lowers the boiling points, that could have helped you out for this.
Okay. Yeah, I see
I mean,
that.
like, of course, B says that it lowers the boiling point as well, um, but yeah, if you just knew that vacuum is distillation is the only thing that does that, and yeah, for the boiling chips, that's a little harder, I guess, to kind of think about, because when you
Yeah.
lab and stuff, I don't know if I don't remember them ever kind of like teaching.
I
Yep.
Yeah, I just remember it was like mentioned. It's just like, oh, why are we using this? So it decreases volatility. That's what I remember saying. Okay, and just move on. And it also kind of mixes the liquid as well.
Yeah,
Um,
yeah, because
yeah,
if you're
in
boiling, yeah.
in the presence of like a magnetic field.
Mm-hmm.
So, yeah.
Yeah, because if you're boiling something, yeah, you're adding heat to it, and then it starts to like bubble. Um,
Mhm.
I guess. Well, I mean, I guess like in a regular example, like it would start to bubble, but I'm trying to think of when if it doesn't bubble up right like that, and it just kind of gets hotter and hotter and hotter, um the bubbles that eventually do form will be kind of like inconsistent and could cause like uh it to kind of like the liquid
Yeah.
to get really really hot. So yeah, so the boiling chip can provide like a nucleation site for bubbles to start forming, so that they can kind of like uh leave the heated liquid, um
Yeah.
to prevent the liquid from being superheated, in which case, you know, it would be it could be kind of dangerous in that it can kind of like shoot out or something like that.
Right. Yeah.
But yep, so that should be that.
Cool. And then next one here um, was talking about liquid remaining large. Just make sure at the end. Oh yeah. So this was also confusing me. Um, so I said, mixture consisting of roughly even. I did the same thing twice. I put this answer in both times.
Mm-hmm.
Mixture consisting of roughly even amounts of the two components. Um, I don't know. For me that it made sense. They look like these two molecules are structurally very similar. They're just I believe they're just like enantiomers of one another. So I thought, okay, well, if they're similar, potentially similar boiling points, um, and there's leftover at the end, it must be that just didn't boil all of them out. But
Yeah, let me see what the experiment is here.
sure.
You can pull your thing up. Like
I
your
can pull
yeah.
with what this thing here.
Yeah. Like right
Let's
there.
see. Got it. Cool.
Okay. So Chanel number 5, kumquats. I wonder what that is. But anyway,
Yeah.
I'm guessing it's some type of animal. But anyway, two enantiomeric forms. Separate the two. Wait, this is the undecanal, right? What is that? The AL here.
The presence of a methyl group. Now, or maybe it's
Just the AL part.
the AL. Oh, is that a
What if it ended in ONE?
own would be a carbonyl group, maybe, right? Or ketone.
So, yeah, good. So, what about if it ended in OL?
Alcohol.
AL?
What's it called? Al aldol, is that right? Or
Kinda. What's simpler than that?
oh, it's just the alkane or not an alkane. Aldehyde.
Yep.
Okay.
So, what is an aldehyde?
It's the present. Is it just the presence of a oxygen bonded to a carbon chain, or a carbon bonded to a carbon chain, hydrogen and oxygen?
So, this would be what type of molecule?
Let's see. Al.
So this will be a ketone.
It's ketone. Okay.
Yeah, it helps to know like all of these
Yeah.
carbonyls. So like, okay, if that's a ketone, it's a like a carbon thing. If it's an H, that will be the aldehyde.
Okay.
What if it was an OH?
Alcohol.
If it was
Oh
just
no,
Yep.
carboxyl.
carboxylic acid, right?
Yeah.
What about if it was that?
Amino.
If it was just that, it would be amino, but if it's this
Uh,
carbonyl,
oh, I don't remember. Don't remember.
so it does start with, it's similar to amine.
Okay.
Different.
And I don't remember. I don't. Amide. Okay.
And this is important because this is what a peptide bond is.
Okay.
What about if this was OR, R being like a carbon chain?
Say I don't remember.
Ester?
Ester. Okay.
Yep. And there are like two others, but okay. So here, these are the AL indicates that there's aldehydes here, right? Can you show me where they are?
Yeah. So the aldehydes would be there and there.
Good. Good. So okay, these are two enantiomeric for what's an enantiomer?
Enantiomer is kind of like a mirror image.
Uh-huh. Is it superimposable?
No.
Okay. What else? Like, how can you tell something's an enantiomer?
If it's non-superimposable and is the same molecular formula.
Same molecular formula. Now, So in an enantiomer, well, two enantiomers will have opposite stereochemistry at every chiral center.
Okay. Yeah. So
And
you get chiral centers
yep.
here and here, and indicates opposite stereochemistry there.
Yeah. Do you remember how to find like the absolute configuration, like for this one, let's say?
Oh yeah. So you would take I believe it's the side with the heaviest. So you'd start moving in the direction of the heaviest element. So in this case, you have this carbon is connected to a CH3. It's got a hydrogen, got a carbon with two hydrogens at the next one out, and then a carbon with an oxygen next one out. So it start moving this way. So I think it's, what is that, clockwise? Is that R?
Yeah. So yeah, you could either, so like in this one, they kind of made it nice for us with the lowest priority, which is hydrogen, going into the page. Right?
Right. Yeah.
So it's already kind of set up for us. So then we can say, okay, the highest priority I would say is this carbonyl carbon here, followed by the CH2 that's bound to the rest of that carbon chain, and then the methyl. So this is a counterclockwise thing, right?
Oh, okay. I
I think
see.
it might actually be S.
Wait, so you go from,
Mhm.
oh yeah, I see. So you go highest priority one, and then you have next priority is this long chain here. And then from here, okay, got it.
Yeah. Now, this one down here, it's a little bit harder because the hydrogen that's the lowest priority is not going into the page, right? So
Yeah.
what I would do is I would still do what I did up here with assigning priorities and figuring out if it's clockwise or counterclockwise, and then I would just flip it at the end.
Okay.
So for this one, it would be 1, 2, 3, counterclockwise again, but since the hydrogen is not going into the page, I'm going to flip it. So it's going to be R.
Okay.
Okay.
Got it.
So
Makes sense.
yeah, good. Okay.
Yeah.
So
I think I confused how you're supposed to do that.
mhm.
I think I initially said R. But yeah, this one is the next priority out.
Yeah.
Okay.
So and also the thing with enantiomers is that they rotate plane polarized light a certain number of degrees in a certain direction.
Okay.
And if they have opposite stereochemistry, then, well, they would rotate plane polarized light the same magnitude, but in opposite directions. So
Okay.
if this was rotating it, I don't know, like counterclockwise, like 128 or 28 degrees, this would rotate it clockwise, and it would be by the same amount of 128 degrees. If we want, we can put like a negative sign there. So if we have equal amounts of both of these, which is called racemic, right? The overall optical rotation would be 0.
Okay. I see.
So so enantiomers on their own, S or whatever, R on its own, or D, or L on its own, will be optically active. But if you have a racemic mixture, which is when you have equal amounts of both enantiomers, it'll have no optical activity.
No optical activity.
Yep.
And what is that? Is that like immediately indicative of whether or not you'll have equal amounts at the end, or because it doesn't really mention anything about optics or anything?
Yeah. I haven't taken a look at this yet, but
Okay,
yeah, I think that's what they would. Well, yeah, I need to see what they mean by this because there's
okay,
other stuff. But yeah, if they
yeah,
put equal amounts of both of these, the two
yep,
enantiomers, it will not be
optically active.
correct. Okay, let me see. A chemistry class conducted an experiment to separate 2-methyl-undecanol from 2-methyl-undecanoic acid. Okay, by carrying out a distillation of a liquid consisting solely of these two components. Okay, so they're separating one of these things in figure 1 with a similar thing, but with an acid. And we we could kind of predict what that would look like, right? It would just be something like that, right?
Mhm.
So now we know that it's that and then one of these, right? Um,
Right.
okay, it says due to the high boiling points of these compounds, the class was instructed to carry out a vacuum distillation. Oh, that's so I didn't explain why you would use vacuum distillation, but
Do to separate things that are very similar.
yeah, yeah, or really high boiling point.
Okay,
150, it's like 150 degrees Celsius or whatever is the boiling point. Like
right.
that's high. So
To get there.
yeah, vacuum distillation would lower the boiling point. Yeah. So yeah, high boiling points, they were asked to do the vacuum distillation. They began by placing 200 milliliters of the liquid mixture in a round bottom flask and adding several boiling chips. The solution was slowly heated and the distillate was collected in the receiving flask. Students noted that the round bottom flask still held approximately 50 milliliters of liquid at the end of the distillation. Okay. 150 milliliters seems to have, this wait, round bottom flask. Oh, I'm looking at these because they're both round, but
Yeah,
the one. Okay.
round and then receiving. Yeah.
So, okay. So they have the mixture here with the 200 ml, and then they're left with 50. Wait, yes. 50,
50 in the round,
50.
150 in the receiving. Yeah.
Okay, cool. All right, what else is that it? What else are they
That
saying?
it? I think that's about it. Yep.
Okay, so let's see. The liquid remaining. Okay, I see. The liquid remaining in the homogeneous mixture was most likely are they asking about this over here? Did I miss the word
Yeah. Yeah, I think they're asking about the remaining 50 in the round bottom flask.
okay, let's see, was most likely. Okay, so we're separating some mixture that has both of these things, right? And
Oh, I think I'm starting to see. So there's a classical experiment separate the methyl
yeah, so
from the acid. Okay.
which one should have a higher boiling point?
So, well, I mean, my guess would be that the acid,
Yeah.
but I'm trying to figure out why. I'm trying to remember, is it because of,
Yeah, so mostly all of the time you will see, so like boiling point,
hydrogen bonding?
yeah, yeah,
Okay.
pretty much. And
That's sorry. This is just
true here is
yeah.
true for all carboxylic acids.
Okay.
And so the 2-methyl undecanoic acid is going to have more hydrogen bonding, which means that it will require more energy to break those intermolecular bonds apart,
Mm.
right? So either, okay, it's either a mixture of the two, or it's just the aldehyde, or it's water that somehow came into this thing from the air in the lab, but it doesn't seem like it seems like it's not really connected to, like, it seems like there's no way
Yeah,
water from
they
the
didn't draw
outside.
any like, yeah, they didn't really mention anything like that. Like,
Yeah.
oh, like there was
Almost like
accidentally some water in there
people
somewhere.
see that diagram, or the diagram like over here, as being like open or whatever, but that's not really.
Oh yeah.
And then it's this one, right? So yeah, yeah. So
Okay.
yeah, so this is a separation technique.
So you just kind of have to know about um, the like the carboxylic group being hydrogen bonded to other carboxylic groups, and
Yeah.
that would bring up the boiling point
Mm-hmm.
with respect to the what is it, the aldehydes or the
Yeah, yeah.
yeah.
So the different, so there's the different separation techniques that you have to know. And distillation is one of them. And so each of them have like take advantage of something. So like distillation will
Right.
take advantage of the difference in boiling points to separate something.
Yeah, I think there's also like the filter distillation where you have like
Yeah.
the metal mesh in between.
Yeah, that like coffee filter thing is um to separate, I believe, like solids from liquids.
Yeah, fractional distillation is what I'm thinking of. It's the where it's like separating things at very similar boiling points, and then
Mhm.
it starts separating throughout the different layers because it starts like condensing and then
Mhm.
recondensing back into the liquid or something.
Yeah. Yeah. So all distillations will have this in common, which is that they take advantage of the difference in boiling points. So when you boil something, the thing with a lower boiling point will, leave here and then get brought there, right? So
Yeah.
that's what distillation does. There's also like, chromatography, and chromatography takes advantage of the different affinities for the mobile phase compared to the stationary phase. So yeah, there's a bunch of stuff like that. But yeah, for distillation, it takes advantage of the different boiling points. And
Mm-hmm.
boiling points are dependent on the strength of intermolecular bonds. And the
Yeah.
strongest intermolecular bond is hydrogen bonds. So if you can have hydrogen bonding, which by the way, involves FON,
Mm-hmm.
right?
Yeah.
So for this, we see the O and, the H and stuff like that. So, yep. So it should be,
Awesome. And just remind me again, this column here. So as the water is like, or the liquid is turning into like a gas phase,
Mhm.
is the water simply there to cool it back down to a liquid?
Yeah, like water would be like attached, or like pipes to water will be attached here. Cold
Okay,
water to cool this, but the water itself won't penetrate that. So
right. Yeah, it's just there for
will
cooling.
be,
Okay, I kind of remembered something like that, but I was trying to make sure.
yeah, yeah. It's kind of like
Okay.
water cooling or your PC or something.
Yeah.
Do you like
Right.
build your PC, whatever?
Yeah, I have a liquid cooled PC. Yeah.
Yeah, yeah, yeah. Nice. Yeah, that's pretty much that.
Okay. Sweet.
I think the first like machine gun was also liquid cooled.
Oh yeah.
The
Okay.
Maxim gun.
Wow, I didn't know that. That's interesting.
Yeah, yeah.
The next passage
Mhm.
was a physics one, and this is one that I was reading it and I just had no idea what was going on.
Yep.
Uh, most of these discrete ones I did okay on. Not next section. Look at that.
Oh, the one with radioactivity?
It was this guy.
Oh yeah, this one sucked, yeah.
Yeah, this one was pretty rough.
Yeah. Yeah. Um,
just really like conceptualizing it and drawing out just any kind of. I was trying to figure out how I could draw anything. I feel like I could think of like triangles, right triangles, mostly.
mhm.
Maybe some I don't know, Pythagorean theorem, but I was yeah, I was kind of lost, and this was probably one that took most of the time for me.
Yeah, I remember this one. This one was pretty tough, like just in the presentation of it, because it's hard to kind of understand what information is important, what information it's not.
Yeah,
During the force test with the mechanical stirrup, at what distance from the ankle joint was the force applied? Okay, where let's see, force. Wait, okay, it's this one. So applying a force via a mechanical stirrup and combining the Taylor tilt test with the anterior drawer, consistent values have been measured for an anterior force of 98 newtons and a torque of 13 Newton meters. The mean Taylor tilt translation was 48 degrees, and the mean anterior drawer translation was 5.7 millimeters. Okay, now I think that the tricky thing here is that this
applying what equation, right? And
well, we know it'll be a torque equation, but
yeah,
what could what makes this complicated is that they give us this angle of 48 degrees.
yeah, and the sine of 40 degrees isn't like super.
Yeah.
Yeah.
If we look at the, let's see.
So could you round a 45 and just make it a half?
I actually think the 48 is not going to be anything that we're using.
Okay.
If you look at the drawing here, we can see that this is, where is this? And wait,
Oh, this got 8 or A here.
anterior drawers A, Taylor tilt is B. They're asking about
Oh, wait. So it should
Taylor
be.
test here, right?
So it's like a 0 degree, because it's 90. It's perpendicular to the.
Right? The
Yeah.
tilt. Well, wait, Taylor tilt they talk about here, and blah blah blah.
So
And
yeah, we're not talking about Taylor tilt, but we're talking about, and it says during the force test, mechanical stirrup,
okay,
and they only use the stirrup in the interior drawer. I think.
okay.
I think.
Yeah, so okay, that still is going to be a 90-degree kind of thing, I believe.
Yeah. Okay. I guess that makes
So
sense.
I think that if
Sine of 90 is 1. So
yeah, so let's see, 98 newtons, 13 Newton meters, times 5.7
5.7.
meters. Wait,
Is that right? Yeah, that's right.
that's the mean anterior drawer translation, but I think it's
Oh, is
fine.
it something like up here? They mentioned another
I do see a 90-degree thing. Ankle sprains. Yeah, I think it'll be this over here.
yeah, okay.
And you just have to solve for R.
Oh, okay. Got it. 13 Newton meters. 13 over 98.
Maybe like this.
Yeah.
0.1
About 0.1
meters.
meters.
Well, this is still
Yeah.
not
It's still it's still too close.
we could do it. It'll be 100 meters if I reduce this and increase this. So this means that this is overall, wait, 13, I rounded down to 10. 98, I rounded up to 100. So the overall number that I'm getting here should be smaller, except it's not smaller. It's 133.
Yeah, it's 133, and it would still be smaller than 110. It's tough. So yeah, in these cases, like,
oh wait,
my first instinct is just to slog through a long division, but I don't know.
I'm getting 0.1 meters, which is 100 millimeters, as our. Oh, this is the lower bound. My bad. Because I'm lowering the 13, lowering the numerator, and I'm raising the denominator to give me.
What if you just round? What if you just instead of rounding both, what if you just round up to 100 in the denominator?
Oh, duh! There you go. All right.
Yeah.
Engineer over here. That's much better. Yeah. Good job. Good job.
Sweet.
Yeah. That works out perfectly.
Sweet. Okay.
Yep.
And then, okay, yeah. So that was, I briefly looked at the example they gave over the weekend, and I mean, it made sense. Like after I relooked at it, I was like, oh, I think I looked at it, realized that it was going to take me a really long time, and I just like went with A.
Yeah. This type of like another like a good thing about passages like this, and you'll see more in the blueprint test, is that it just looks horrible, and it is kind of horrible also, but it makes it so that when you're taking like the actual test, when you see something really scary like this, it's like you've been in this position before.
Yeah.
So there's going to be more really crazy passages like this, you'll see.
Yeah, I don't doubt it.
Mm-hmm.
Okay, so the next one, I got everyone but 21 wrong. So go through this real quick. See, during the anterior drawer test, the joint translation occurs in 0.2 seconds. What is the average velocity of the talus during the translation? Oh, I think I miscalculated with my units or my, because I think I got 2.9. And then I just think I didn't do the -2.
So, yeah. So I think they're using that distance.
Yeah, over that distance over this time. And
how would you do this, the math?
The math, well, 5.7 millimeters is what do you got? 1 centimeter for every 10 millimeters and 1 meter for every 100 centimeters. So I'd multiply by 1,000, or sorry, divide by 1,000. And then you get meters from there. So 0.0057. And then there you get meters divided by 0.2 seconds. So what is that? That's 5 points. Let's move.
Yeah, why not turn the 5.7 into a 6? And then
okay. Yeah.
So if I see something in non like standard units, I would just put that like, so I'm gonna make the 5.7 a 6 millimeters, but I'm gonna meters, so I'm just gonna tack on to this
I was thinking about that, but then I saw how close the values were, like 2.9 versus 3, and then I was like, oh, well, I got 2 and 6. Like, it's gonna come out to a nice 3. So yeah.
Let's see, because if you divide it by the 0.2, I also was curious how you would do that.
Oh yeah. So I get 60 -3, and then I got really 2e -1.
Okay, so
So
turn it into 2e-1. Okay, that works.
yeah.
So
So -3 minus -1 would be e-2, right?
yeah, so now this we can consider to be an upper bound.
Okay. Oh wait, yeah, okay, that makes sense. That immediately eliminates all the threes because it's got to be -2.
Yeah, so I
Okay.
see that you're thinking like, okay, 2.9 and 3 are really similar, so that you're not going to want to round it,
Mm,
but you could still round it. But when you round it, you'll at least get either like an upper bound or a lower bound, and you can go from there,
okay.
right? Um,
Yeah.
something I could have like just like to show like another way of possibly doing this, like because this works and it works nicely because 2 goes into 3 evenly. But
Mhm.
I like to take like if 0.2, I like to turn it into 1/5.
Oh yeah.
If I do this, if I divide
That's a
it by
yeah.
1/5, it's the same thing as multiplying it by 5, right?
Mhm.
So that'll give me 30e negative 3,
Yeah.
which is
Yeah.
maybe 3e left subtract right add, same thing. But
Got it.
yep.
Sweet. Yeah. That works out.
Mhm.
Yeah, I just made a dumb error there. But I think
Yep.
I did it at the same time. Yeah, I did it twice.
Mhm.
I did it wrong both times.
Yeah. It could be kind of like I mean like for me to go from this to this, I like say out loud in my head like the 30 into 3, I say left subtract right add.
Okay.
And if I
Yeah.
go from here to here, I say left add, right subtract. I literally say that every time I do it because it's so easy to make a mistake.
Okay. So right add left subtract, is it?
Yeah, like so let's say I have 0.5 E9.
Mhm.
I'm gonna make the 0.5 a 5. So I'm gonna say left add, right subtract.
Left add right subtract. Okay. Yeah.
And if I have 500 E4, I'm gonna make the left just 5. So I'm subtracting by 2. So left subtract, right add.
Okay. I see what you're doing there.
Yeah.
That's a good strategy.
Yeah, because it's like just so easy to mess up.
Yeah, it's
Like, with the
really,
math,
really
like
easy.
I'm not gonna be like a rock star and do it like super fast. I'm just gonna do it in a slow, systematic way, minimize
Yeah,
minimize the error.
definitely the best method there.
Mhm.
Um, okay. Uh, that's definitely something I should kind of practice. And I will go to the next one here. Okay, yeah, this one,
Yeah. Oh,
like I was pretty frustrated because I feel like I got really close, and then I kind of fizzled out at the end. Uh, so if a 90 kilogram man undergoes a turning acceleration of 5 meters per second squared during a running turn, what is the magnitude of force experienced by the foot to the ground? I was gonna like I'm gonna stop sharing here real quick, and then I'm just gonna share what I was thinking here. Um, okay. So yeah, I was just thinking initially that I have kind of like it's the right triangle almost, um,
hmm.
where you got the 90, um, 90 kilogram man, you get force, or I guess gravity. Yeah, I guess the force here equals the mass times acceleration, and then you got the turning force going the other way, which was the acceleration. I guess this would be mass times gravity, mass times acceleration. And then the resultant would be your magnitude of force experienced by the ground. So let's see. So you get 90 kilograms. And then your acceleration here would be the 5. So basically you got 90 times 10, so you get 900 newtons there, and then you get 450 there. And so you got your classic like Pythagorean theorem situation going on. So I just kind of plugged it in. 900 squared plus 450 squared is equal to c squared. C is equal to root 900 squared plus 450 squared. And I think at this point, I don't think I saw it, but you just factor out like a 9 from here, 100. So 9 times 100, I guess quantity squared, times, let's see, you can go to get a 5 and get, was it 90? Yeah, see what else people take out here. I don't know.
Why don't you try just taking the 900 and putting it in scientific notation?
900 and putting it in scientific notation?
Yeah, like in parentheses 9e2.
92.
Yep, in parentheses, and then square that.
Yeah.
And then
Plus
450, just round it to 500 or 5e2.
Okay. 5e2.
Yeah, in parentheses and square that. Because now, like, for the 9e2 to square it, you would just have 81 e4, right?
Oh, yeah. So, yeah. Okay, I see that. So you get 81 e4, 25, e4. Okay.
And then that'll be like 106 e4. And you can square, like, you can make the 106 100.
Okay, yeah, 106. Okay, yeah, that makes sense. And then you can just round that down to 100 and make it approximately
10 e2.
10 e2.
And this would be the upper bound, right?
Yeah, because you're rounding. Yeah, you're rounding up.
Yeah, for the 450. So we need our answer to be larger than 900, less than 1000.
Okay, and then it ended up being C. Yeah, larger than 100, less than 1000, or 900 less than 1000. Okay.
Yeah, I think C is like A was 450, B was 900, C was 990, 10 D was 1075.
Yeah.
So I think that I think when you see like similar values, it can discourage you from rounding. But when you round, it can help you establish like either an upper bound or a lower bound, and that can help you with the answer if
Okay.
close, right?
Yeah.
Mhm.
Yeah, that makes sense. So yeah, I don't know, I think I just kind of got lost there. And this was on my second attempt that I did that. Like the first attempt, I had no idea what was going on. Just kind of
Yeah. I know I remember those values because pretty much everyone gets that question wrong.
okay.
Even ChatGPT doesn't get it right.
Oh, really? Did someone try it?
It's pretty ChatGPT's pretty crappy at MCAT problems, to be honest. Because like it's not really able to take like the implicit information. Like for this question, ChatGPT, you plug it in, it's just going to tell you the answer is A because it's not because it
What?
explicitly says 90 kilograms and 5 meters per second squared. So it's just gonna multiply those two. Um, so it's not good with taking like implied or implicit information.
Okay.
But yeah, yeah. Yeah, see, a huge, tremendous amount of people chose A.
Yeah, I saw that. Like it's
Mhm.
crazy. I think it's just
Yeah, you're not alone.
all right. Yeah. I'll work on that. But I mean, you just getting the right answer on some of these, like
Mhm. I mean, you set it up perfectly.
yeah, it's I don't know. Like when I looked at it later, I was like, oh, this just looks like this looks like a right angle problem, a right triangle problem. That
Yeah. Yeah, and
uh,
also like the math that they did here is kind of weird. Like I wouldn't do it that way.
no, yeah, I was
Oh,
looking at
That
that
that's what you
too.
you were doing with the factoring things out, I think. Right?
Oh, yeah, yeah.
Yeah.
I was gonna start doing that, yeah. But yeah, they did oh, okay. Yeah, now I see it. Right?
Yeah.
The 45. They got 90 for everything, and then you just get
Yeah.
that. Ooh, yeah, okay.
That's
But yeah, this right here, this math magic that they do here with the 125 to 121. I mean, I guess like
oh,
the
they're just
next
doing
square
like
down.
the next
Yeah, next square down would have been 11.
yeah.
So, yeah, okay. But you have to see that like
Mhm.
almost immediately. So
Yeah. Yeah.
anyway, so let's go to the next one here. Yeah, I got that one right both times because it literally says you can't go greater than
Mhm.
yeah. So anyway,
Newtons.
right. And 22 I got right here. They're more likely to occur in individuals of a very low body weight. I got that one right here, but I think I got it wrong in the next time I did it. I think it chose D.
Wait, when you're doing your blind review, are you doing everything or just the ones you got wrong?
I did everything.
Oh yeah. You only have to
I
do the
thought
ones you got wrong.
okay, gotcha.
Or you got something right from guessing.
I'm pretty yeah. I think that's what happened here. I think I
Okay.
got so I just did it all. I did it all blindly. So I just looked at my score report and said, okay, got a lot wrong in in this area. I'm going to try that one again, and then I did it again and got some wrong that I got right before.
Got it.
So in this case, that's seems to be what happened.
Hmm.
Uh,
I looked up
Granted-
kumquat and it's some type of fruit that looks like an orange.
oh wow.
For some reason, I thought it was going to be like some type of um, like, because you know how like a lot of like stuff. perfumes and stuff used to be made from like sperm whales or something like that. I thought it was gonna
I
be some
didn't I haven't heard that, but that's
Oh yeah,
interesting.
yeah. That's why,
Yeah.
like, most whales were like when whaling was a thing, like in the 1800s, like most whales were like became extinct and stuff.
Yeah, I thought they were doing that for like oil or
Yeah,
something.
that as well as
Yeah,
a lot of other stuff, I think.
yeah, that's really interesting. Um, yeah, I think maybe second time over, I didn't read it close enough or something. But they're more likely to occur in individuals with low body weight because it literally says, obesity is
Hmm.
one of the contributors,
Yeah.
and build up ankle strength, enable to build up ankle strength. And it
Yeah.
says that somewhere. I think it says that somewhere in here too. So yeah, I just got to pay attention.
Yep.
Let's see. Let's go over.
Something called ambergris is the thing that comes from sperm whales that they used in perfumes.
Oh, okay. Ambergris.
Yep. Yeah, I remember reading Moby Dick and learning about a lot of that kind of thing.
Okay. Yeah. I don't think that wasn't one of the things I read in high school. It was probably an option, like
Oh,
for book report material. And I think it chose something else.
yeah.
I should read it.
Yeah, it's pretty good. They go into really in depth with a lot of the stuff about whales and stuff. I know that
Sounds
the sperm whales also have like the highest decibel sound, like of any bird, like so much
yeah,
blue.
that's really cool. Like even more than dolphins.
Yeah, it's
Wow.
sperm whale clicks can be as loud as 230 decibels. A jet taking off is around 150 decibels.
Oh my
And
gosh.
I think that the Saturn V rocket is the loudest human made thing. 203 to 204 decibels.
Dang.
It's more than that.
That's incredible. That's really cool.
Yeah, it's pretty insane. Okay. Captive Pro. Okay, yeah. So this is a good thing to go over regarding in titrations. Like what is an equivalence point in titration?
So the equivalence point in a titration is when uh, you let's see pH. So it's where you have like an equal charge, maybe. So it's not like um, so your molecule has an equal amount of positive and negative
So
charge distribution.
so I drew a little like thing here where the thing in this beaker is called the analyte,
Mm.
and the thing in this burette is the titrant. And let's say that the analyte is an acid or whatever, and
Mm.
the titrant is a base. Um, in our x-axis here, we can have that, be volume of base added, and the y-axis could be the pH. So if we're saying yeah.
So is equivalent point just the the point at which the pH becomes neutral?
So that could like be a something that happens coincidentally,
Okay.
but like it will in this kind of example because I'm gonna have the analyte be a strong acid like HCl, let's say, and the base a strong base like NaOH. So as we start to add some base, the pH will be low because this is an acid, like a strong acid, and it'll start to go up, and then boom, it'll become quite vertical. and then it will kind of flatten out again. So the equivalence point will be here, which will, yes, if it's a strong base titration would be like at 7. But that's
So
just circumstantial.
substantial, yeah.
The equivalence point is something very, very specific, and a lot of people will say different things about it. Like, sometimes people say it's when the concentrations are equal, but
Mhm.
concentration, I kind of use like the analogy of like concentration is kind of like weight, meaning you can weigh something on Earth and weigh something else on like the moon. Concentration could be high in one case, but if you add solvent, it could be low.
Okay,
So concentration isn't really that reliable in telling us like something about how much some like physically something there's of like how many like what number of molecules. So for instance, like if we had HCl and NaOH, each molecule of sodium hydroxide will neutralize each molecule of hydrochloric acid. So we really want that equivalence point to be when the number of molecules are the same, right?
yeah.
And a mole is basically that. Like a mole is just Avogadro's number of molecules. So the equivalence point is when the moles of the analyte are equal to the moles of the titrant. And
Okay,
moles stands for the number of molecules. So it's
okay.
moles is more like mass. Like your mass doesn't change if you're on Earth or on the moon or on Jupiter. Um,
Mhm.
just like the number of moles doesn't change, but molarity can change based on the solvent, just like your weight can change on the moon. So,
Right.
so that's the equivalence point when the moles of the analyte are equal to the moles of the titrant. Now, the analyte, so the titrant we add like, drop by drop, right?
That makes sense. Okay.
But
Yeah.
we don't know how many drops it'll take. But the analyte, we don't change the number of the analyte. The number of analytes that we have is not changing. So if you can figure out the number of moles of the analyte, that will have to equal the number of moles of the titrant at the equivalence point.
Gotcha. So
Yeah.
then you just your goals trying to find the.
Yeah. So you can see down, yeah, so they're using the captopril as the analyte, and then they use this sodium hydroxide as the titrant. And if we look at this, yeah, this graph down here, we can see that it's pretty much what I drew here, with the x-axis being the volume of titrant added, but the y-axis is cell potential instead of pH. But it'll still give us like kind of like the most vertical region here, which will be when you have, I guess, like roughly put like 7.6 or 8 or something like that
Okay.
of the sodium hydroxide being added. So let's say that that's 7.5 milliliters of the sodium hydroxide. So they gave us, did they give us the molarity of that?
The molarity, yeah. So sodium hydroxide is 2 times 10 to the negative 2.
Yep, yep. So we can take that 7.5 milliliters, or I can just turn it into liters by tacking on an E negative 3 liters, and then multiply it by molarity, because molarity is moles per liter, and so liters will cancel out and I'll get the number of moles, so 2E negative 2. this is going to be 15 E -5 moles. Of
Moles.
sodium hydroxide at the equivalence point,
Mhm.
right? So
Yeah.
So yeah, now we just have to look for that in the choices. So we can get rid of the 7.5 stuff, right?
Yep.
And then let's see, we can put it in. Well, if this is it in moles,
Yeah.
it can't be that, right?
Right.
So it would be this, but let's just make sure. So this is, I'm going to do, or let's have you do the thing with the left side,
Yeah. So
right.
you're going to add going to the left. So um,
So on the left, if I want to go from 15 to 0.15, I would subtract, right?
oh, you're wait a second. So you had -5, -4, -3, right?
Oh, so basically I would do like 15 to 0.15, right?
Mhm.
So it's kind of like weird. It's not like I'm actually subtracting or adding. It's just that if I'm moving the decimal point over to make it smaller, I say subtract. So it'd be left subtract by 2 points, like 2 decimal points to give me the 0.15, and then
Okay.
right add by 2 to go from E-5 to E left subtract right add. So yeah, E-3.
Okay.
So
Yeah.
this would be 0.15 E-3, which is 0.15 millimoles, right?
Millimoles. Yeah. Okay.
Yeah.
Gotcha.
So this is kind of like the reverse of what I was like gonna say, because like you can find if you wanted to find the amount of titrant at the equivalence point, it would be equal to the amount of moles of the analyte. But here it's like we don't know anything about the moles of the analyte, but we know how many moles of titrant will be at the equivalence point, and that will have to equal the number of moles of the analyte, which is captopril. So that's why, we can solve it with the titrant as well.
Okay. Yeah, that makes sense.
Yeah, so just make sure you remember equivalence point is when the moles of the analyte are equal
Right.
to the moles of the titrant.
Gotcha. Moles analyte equals moles of the titrant.
Mhm.
All right. I'm just gonna take a screenshot of that real quick, so I don't.
So you built your computer. Does that mean you game?
I do. Yeah.
What do you like to play?
Right now, I'm really into Helldivers.
Oh, I hear that. That's like the thing that's kind of like Starship Troopers.
Yeah,
Have
it's
you ever
really cool.
Insurgency Sandstorm?
Yeah, yeah. I have heard of that one. It's a classic FPS, I think.
Yeah, it's like super, super realistic, like, in every way. It's pretty awesome.
Right. The other one I like to play is Arma. It's
Oh
another
yeah,
like,
yeah.
yeah,
That's another, yeah,
very
fast.
hyper realistic.
Yep, yep.
Yeah.
That and like Tarkov and stuff.
Tarkov, yeah. So I love playing those.
Mhm.
They've got a big like Discord of guys from all over the place, and we
Yeah.
hop on there and
Yeah,
have a lot of fun. Yeah.
nice.
Let's see. Okay. Yeah, this is Michaelis-Menten, or um, I I think I spent a lot of time like reviewing Michaelis-Menten, and then it seems like the further I get from that study sesh, the more I
Yep.
forget about it. Because there's a bunch of relationships between the different kinds of inhibition,
Mm-hmm.
whether it be like competitive, non-competitive. Um,
Uh-huh.
yeah, and so I always forget like what it's doing depending on the kind of inhibition it is.
Yep.
Um,
So
so
you could think about, let's say this is an enzyme, and let's say this is the active site of the enzyme, and substrate goes to the active site, gets turned into the product. So if you have an inhibitor that also goes to the active site, it must be competing with the substrate, right?
right. So you'll increase the amount of substrate in solution if it's directly competing
So that would
with
be
it.
a way to overcome the presence of an inhibitor. What's KM, by the way? What does that mean?
That's it's the I know it's the amount of substrate in like the substrate at like the equivalence point or halfway between. It's like cans 1/2 Vmax or something.
Yep, it's a substrate concentration at 1/2 Vmax, right? And Vmax is the max like rate of that uh enzyme being able to turn substrate into product. So
Yeah.
so uh so if you have a competitive inhibitor, it will be competing for that active site, which means that it will cause the Km to increase, meaning you need to have a higher substrate concentration to achieve that same 1/2 Vmax rate.
Okay.
And this can be overcome if you increase the amount of substrate. And that's pretty much what's meant by increasing the Km.
Okay.
So that's competitive, and you can tell if something's competitive inhibitor like in a passage, because they'll say something like it looks like the substrate, right? Or it competes for the active site or something like that. But yeah, that's not going to change Vmax, but it will increase Km. Um, and then you can have the things that bind to not the active site. So if you have, let's say, something binds to, let's say the inhibitor binds to some location that is not at the active site, it can cause a conformational change or an allosteric effect, which
Oh
can
yeah.
make, change the shape so the active site isn't going to be working that well. So that could be like a non-competitive.
Non-competitive. That's the other one. So there's competitive, uncompetitive, and non-competitive. That's the other one I was forgetting.
Yeah, yeah. And so the non-competitive is going to have the Km unaffected, but Vmax will go down because it kind of messes the entire enzyme up, and you can't really overcome it.
Yeah.
And then there's uncompetitive, in which Km goes down as well as Vmax. So you can typically see that like when you have like the Michaelis or the Lineweaver-Burk plot, um,
Yeah.
you'll see both lines being parallel typically.
Yeah. I remember that graph.
Mhm.
So the uncompetitive, and then Lime Weaver Burke is was it like a it's like negative? It's like a negative reciprocal or something. It's like a
Mhm.
negative reciprocal plot.
Yeah, yeah, you would have like 1 over V, 1 over S, and
Yeah.
if it so if it touches this line here, it'll be
That's KM, right? Or 1 over KM.
Yeah, let me make sure here. So the x-intercept is going to be 1 over km. The y-intercept is going to be 1 over v max, and the slope will be km over v max.
Okay. Gotcha.
And then there was one last thing about what it binds to. So the non-competitive will bind to the enzyme or enzyme substrate complex with equal affinity. And the competitive will just bind the enzyme, and the uncompetitive will bind just to the enzyme substrate complex.
Okay.
Yeah. So, yeah. So if we look at the choices, A says Vmax decreased, km unchanged. So that would be non-competitive, right?
Right. Yep.
And then B, Vmax decreases, km increased, nothing. Oh, well, it says certain mixed inhibitors. Those can also exist. In which Vmax will decrease, but km could increase or decrease. They'll typically give you more information for that, I believe. C, Vmax unchanged, km decreased.
Okay. Yeah.
I don't know what that would be, but they're saying
Yeah.
a reversible thing. And then Vmax unchanged, km increased is the competitive.
Yeah.
Apparently they said in the passage that it was a competitive thing. Yeah, here it is.
Yeah, there was.
Yeah.
Okay.
So yeah, you're going to be asked like questions about enzyme kinetics like all the time. So
Yeah.
very,
I'm
very
gonna probably review that one again, just go over a chapter or something and read that. Because I remember after I reviewed it, it made a lot of sense.
yeah.
And I was doing like what's it called? Um,
Anki.
uh, it wasn't Anki, it was the UWorld. I was doing a bunch of UWorld questions on enzyme kinetics, and I was doing pretty well. It's just been a while since I've looked at it. Just gotta
Yeah,
get.
yeah. Yeah, a lot of them will also like to tell you like the active site contains these amino acids, and they usually have something special to do with them.
Okay.
And then like if you change them into like alanine, you might get loss of function or whatever. But yeah.
Okay. So just kind of recognizing the difference between like an amino acid specific passage to a like an amino acid enzyme acting passage or something. Okay. All right, and then let's see, what was the next one here? File, get that one down. Okay, I think probably. Let's see, we're already about an hour 25 in. Is that right?
I think an hour 40.
Oh, we're an hour 40 in. Okay.
We started at 5:30. So, and it's 7:09 for me.
Okay. Did I log in? Okay, yeah. Okay, so honestly, we should probably just end it there.
Sure. Got it.
So
So
yeah,
let's see. When would you like to meet next?
yeah, let's try to meet. Well, let's maybe next either next Wednesday or Friday would work.
Okay.
I'm gonna try to get another exam done here on Friday.
Yep.
And keep chugging along with that. Yeah, really, like the big thing I notice is just the timing at the end. I get like pretty consistently like through like halfway through the exam, and then I just like biff the last 30 questions there.
So like essentially like right. Yeah.
Sorry.
Go up to the CP. So essentially here, I'll draw lines.
Yeah.
Checkpoint here. Checkpoint here. Checkpoint here. So those are the checkpoints essentially where you'll be given a chance to adjust your pace. But I think that will help. And
Yeah,
want to aim to have the max time spent, aside from like the questions that involve the time for reading it, you want the max time to be like around here, 1.5 minutes. So that's what we want to look for on the next test.
okay.
Oh,
Sounds good.
And yes, for the cars, right? If you go to like jackweston.com, I'll show you what I mean about.
Just the question, practice exams. Yeah.
So you see there's this Los Angeles one, Chicago one, and there used to be more, but oh wait, maybe hit that. It's probably just the same thing.
Yeah, it looks like it's doesn't change.
So for the next test that you take, like do it like normal, but once you get to the car section, open in another tab this page and do the Los Angeles cars exam and do it like it'll be timed and all that stuff.
Okay.
Use a score converter likely, but do this cars exam, and then when you're finished, go back to the blueprint one and then resume that BB section and psych soc.
Okay. And what do you mean by score converter? Is it like scaled? Or...
Oh yeah, like because this is gonna give you like a raw score, so you can score converter. Like the one I usually use is just this one. In the chat. So yeah, so continue finishing up reviewing this test and then when you take your next test, use the timing checkpoints in addition to not letting questions take longer than 1.5 minutes. If they do, guess, flag, move on, come back to it if you have time, and do the Los Angeles cars exam instead of the blueprint cars section. And then, but for the rest of the sections, do the blueprint. And yeah, I think you'll do well. And then we'll meet at some point after that. Do you want to meet on Wednesday the 10th at 4 p.m. Eastern?
Wednesday the 10th, 4 p.m. works. Yeah, that works for me.
Okay. Got it. And let's see. It'll be 1:32 for today.
Cool.
All right. Awesome. So good luck on that test. Have a good.
You too.